results that you can have. For one of the wells, we decide it's 5%. For another well, based on data, we decide it's 10%. So we've seen that here, 5% is better than going to 10% for this well. Okay. Guys, yeah. So I'm not going to explain too much of all these equations, Darcy's law and all of that, but my petroleum engineers can come here and design Darcy's law for you. But essentially, in petroleum engineering, the lower the contact angle, the better the wettability, or the higher the wettability. So if you see this, if you look through, we'll see that what we want to produce is oil, right? And if you notice, where we have less than 90 is where we have a better contact angle. So that lower contact angle, when it's flat on surface, that means it's just on it. But the contact angle less than 90 actually is where the wettability is best for us. So once we have it less than 90, we now know, okay, this thing is actually unlocking the oil. So there are tests, there are different kinds of tests for testing wettability, testing contact angle, as it were. There's the singly test for testing contact angle, and there are many other good tests for testing contact angle in industry. But this is just giving us that overview that, look, it's contact angle less than 90 is high wet, water wet, and that's what we want. We want to change that wettability from oil wet to Xyme wet / water wet. All right. So next slide. The next slide is just showing us a lot of data around. Guys, next slide. Okay, so like we've seen, you see, as we keep going, we see that in degrees we are reducing, right? So by the time we reduce, we have now seen that the reduced rate is 100%. So the better it gets down that part, the better for us. The better, while lesser than 90 is the better for us. So at this place, if you see here, you see that the reduced rate for limestone, which I told you about, is better than when it was. 13% better than when it was, but it's not as good as what we had, or what we have, with sandstone. So again, we are always open to tell you that, look, you are not going to get the best results in a limestone asset, but it's still a good result. Again, still the same, just sharing all of that. So I'm adding 100% Xyme. You see that it gets better to 2 degrees. So that contact angle keeps reducing at under 10 minutes. So adding again contact angle from 0 to 30%, you see that the contact angle reduces from 125 to 32 degrees, which we want that contact angle to be reduced. Next slide, guys. Okay, so where do we apply the Xyme? Where do you think it works? It works or how does it work? How does it work? So it works, and I'm going to show maybe in the next slide also what are the immediate or quick evidence to show that the Xyme is working. So what it does in oil and gas, we always speak to recovery factors, and what I shared around 15 to 20%, that's a recovery factor. So we say primary to secondary, your highest recovery factor is 20%. Then by extension, they will also tell you, if you study reservoir engineering to some point, they'll tell you the best you can get for recovery factors is 30, 35%. Some people argue 40, but it's what it is. But we've seen that in elongating the life of a well beyond the primary and secondary recoveries, trying the Xyme, pushing the Xyme, elongating. So maybe you produce the well, and I'm going to show you a chart that shows that you've done a well, and the well, after 2 years, it just dies. You understand? And you don't have the money to go and do a major rig workover. But the oil is there. You've done saturation logging, MWD, LWD, prior to running hole. Then maybe now, because you have a cased hole well, you can't do MWLW, you now do what they call carbon oxygen logging. So you must have heard of different kind of tool. Oida has a fantastic tool called the Prism X. So it can tell you where your various contacts are. So you have seen that the oil is there, but chief, this thing is not coming to surface. You understand? Adding the Xyme in those kind of wells is where can help you unlock that oil to surface without necessarily having to do a major rig workover or getting to bring bigger equipment to a location to get oil to surface. So it extends the life of the well. So we are going to show you. I'm going to put a chart to you where it will show you that. Okay, so if the well was supposed to die now, maybe just did it 3 years after it died. Add Xyme to it, it increases. So if you are doing maybe you started at when you initially drilled the well, it started at 500, and it dropped to 50 barrels a day. Once you add the Xyme, it might not come back to 500. Your initial production comes to maybe 400. It will go again for some few months or a few years, then goes down again. As it's going down, getting close to 50 barrels, you add Xyme again. It comes up again. So in that way, you are elongating the life. If not, if you didn't add Xyme, you'd have just died after the first three years, right? But now, because of this, you are elongating, and that's what that last point is explaining. All right, next slide, guys. Okay, so this is just kind of talking about weightability. So you are still seeing that, yes, there's still that we start trying to reduce that contact angle in limestone, but if you see that of sandstone, it's already clear even at stage 3, nothing is acting in that direction. I just try to put this there. I should have put it in a slide immediately after, but this just kind of further buttressing weightability. Next slide, please, guys. Okay, so they are multi-use beyond, we were saying we use it to release oil and unclog a particular reservoir. So there's use beyond that. So people have told us that in wells where they have high paraffin, high wax, they've gotten better results. You understand? So it's some places we added, there's a pipeline out of the country where was clogged, was always producing too much hydrate. We applied it as part of this thing. We pumped it and all the hydrates went out, So it's, and people have argued, can it be used for gas? No, we don't recommend it's used for gas, but the results I will share at the end would also give some insight into the effects we had from a gas well. So also it can be used together with other enhanced oil recovery chemicals, as it were. So ESP, polymer, surfactant flooding, all of these here, the ones that are very commonly used in Nigeria, polymers, then acid and caustic treatment. The hydraulic fracturing is always used majorly in fracking. So I'm sure when Trump came the first time, he told you, say, go drill, baby, drill. And what they were doing majorly was frack. So it's more of those hydraulic fracturing. They frack their wells there, because most of their wells are limestone wells. And the kind of wells they are going to see in the place they just, quote unquote, captured, Venezuela too, is that kind of thing in limestone, a lot of limestone and carbonates also. And in petroleum engineering is, to define what skin is that something that causes an impairment immediately close to the well bore from not allowing oil flow the way it should flow into the well. I can give a technical definition, but I'm just trying to define it in a layman's term. So what you do is to apply acid and see if you can just peel off, supposedly. Why it's called skin is also stemming from the fact that it's just supposedly just a small layer, but what it causes most time, because it happens across maybe 100-foot perforation, its impact is always large. So it's just on that surface. By the time you add a little acid, it might just take it off, and as such have all all your crude oil come out to formation. It can happen. If I had this in here, I'll draw it for you, where it can happen across the entire part of a perforation. And you see, when we drill a well, we also perforate it to make holes to allow the oil drain into the well, from the well to surface. Across that part, that skin can impact. But using acid prior, to adding Xyme can help you clean out and reduce that skin effect. Then when you now add Xyme, it now helps you unlock more of your oil. Next slide. Okay, again, just further stressing those points. So water flooding, steam, huff and puff, thermal, then also with oil, old and new well repair, you know. Next slide, please. Okay, so, you know, I'll just play. I think I have 1 or 2 slides that I'm just, you know, playing up and down. So one of this is just to show you, if you go by primary and secondary recovery, you're just going to have, it's still a short life for your well. You need to be thinking of tertiary, you know. You need to be thinking not just of tertiary, but of Xyme beyond that point. So if you are going tertiary and you are not using Xyme, it's still a short life. You need to think of going the Xyme way. All right, next slide. Okay, so this is what I was trying to say when I was saying I was going to show you a chart of the life of different kind of wells that we have in the industry. So first, should be the ideal well. You understand? The first time we perforate it, we case it, producing it to surface. Oh, it's doing 200 barrels, you know. Then after years, so this is 1995. Then when we get to the marginal line, that marginal line is just there. Where A is, when we get to the marginal line, around 10 barrels. We're just using hypothetical numbers. 10 by mathematicians should tell me. 1995 to maybe like, let's put that 2016. That's, you know, that's over how many years? 21. 1995 to 2016. 21. You see? Brilliant guys. I didn't even know that in my head. Yeah, so that number of years you've produced and keep producing, you're making your money back. But now, this is the way it should be. So after 20 years, this is the way it should be. But now let's look at a well that is underperforming. And now we have that datum, right? So now a well that is underperforming is going to be performing below that line. And as such, if you see that, it's now coming now to 2014, 2015-ish, because it's underperforming. It's not performing at the optimal, which is because there's no how. Once you open your well for the first time, it starts depleting. You understand? It just starts depleting. But is it overperforming? Is it underperforming? Down here, it's overperforming, because if you see that same green line is on top of our baseline. So meaning that instead of it stopping in 2016, it's dying actually. So even if I put it on, it comes on when the battery is down. Can you guys hear me now? All right. Thanks for bringing that up. All right. So the water well I was telling you about, that some people just are so fortunate. Let me put it like that because I don't want to say it any other way. They're so fortunate that instead of I'm getting 20, at least first 21 years, like mathematician told us, they are just getting 2 or 3 years. So immediately it just comes up, it just dies. You know, that is a very poor performing oil well. So these are the kind of wells that we see in the industry. So somebody just say, you did a well, it is just watered out. Oh, we did you did a well, it produced for us, we have made our money, but you know, or it's doing more than we thought it would do. Somebody will just tell you, we were thinking it was going to do 300 barrels. It's not doing 1,000 barrels. You think that's you just immediately know that's an overperforming well. All right. So these I just gave this as an you know, one kind of just giving you an idea of the kind of wells that we see in industry. Next slide, guys. Okay, so this design, the way I was telling you that design will act. So when you apply design, immediately, so you finish producing it, you now apply design, it will come up, start reducing, apply it again, come up, start reducing, just like that. So that's the way you are going to be. And I guess maybe one of our smart engineers is going to now maybe get a chart and show you some further insight into this. But the point is that what Xyme now does is to now elongate. So that thing that you were thinking maybe for that poor performing well that will just act only after 3 years and die, you can now actually extend it to that 20 years by applying Xyme intermittently. So it's going down to back to 50 or to 10, sorry, that we saw. Bring it back up again with Xyme. Applying Xyme, it brings it up like that. So continuously till you are maybe now saying, okay, maybe I need to drill a new well or do something else other than applying Xyme. Next slide. I think I still have some data here. So so this like the capillary test. That capillary, this thing I was showing you at the beginning, how oil comes out. So by the time you add Xyme over time after 72 hours, and that's the essence why I told you we lock in, and you understand why we lock in the Xyme. When we lock it in, we see that the release of oil increases. The release of oil increases. We don't just put it in and one day it goes out. No, we just lock it in so that yes, that percentage of oil recovered from that keeps increasing and increasing, and that's what you see as it goes. Immediately we are releasing from that capillary. That push that I showed you from that diagram here. I said Xyme was entering from the side and it was unlocking it. That's what is happening here. This is just like a lab test showing all of that. Next slide, guys. Okay, so this is a chart explaining what I was telling you, why we lock it in and what now happens exponentially after that. So here we have applied Xyme and we locked it in. So we lock it in after 2 days. Boom, you see it increases. So immediately it just increases going up. So we at every point in time we soak it minimum 3 to 5 days and we get that exponential result. Next slide is the same. I think I kind of, this is one is in okay, this is Brazilian oil. I think the next slide I think that's Norway crude oil. So the same kind of results, exponential increase. Okay, next slide, guys. I think I need to speak to permeability now. So the unclogging this thing, yes. So this was what I was saying, where in a high permeable well, your Xyme works better. So this are two sands. One is low permeable. One is has a higher permeability. But see the results. It has supposedly improved, maybe not so much from when it was initially, but going through this thing, it was improved. But see how this other one too has gone at that end, because we added 10% of this thing. So that increment it works better when the thing has higher permeability. Next slide, please. Okay, so this is me trying to just, because they told me I should prepare for a technical this thing. So if I tell in petroleum engineering, we use K for permeability. You understand? My petroleum engineers are nodding because they know that well. So we use K for permeability. I can't explain all of that, but let me not take you through all those motions. If you want discussion, we can discuss it one-on-one. So next slide. So it's just the same thing I just explained there we are doing here. So same permeability. Next slide, guys. The data. Okay, so question is just reservoir management with Xyme. So can you afford not to do well interventions? So you say, you said died after 3 wells, let's leave it. Can you afford not to do it? Then again, can you afford to use the wrong solution? Because you now still further damage this thing. Why don't you apply Xyme? So if you apply the wrong solution, it will shorten the life of your well. Next slide, guys. We're almost running up. Right. Okay, so there are various types. I've been mentioning them: freshly drilled wells, old wells, horizontal, vertical, lateral. It all applies everywhere. Carbonate, limestone. Yes, but I told you, and we're open about it. Limestone is not, it doesn't have so much result except you frack before you apply it. So yes, next slide, guys. Okay, so these are the results I was speaking to. What are your first signs when you apply design? What's the first sign you see? So your static liquid level will increase first. So what some people always do to test, they'll say, let us go and tag fluid level before you even apply your Xyme. So this is their let's tag fluid level, and what they do is to go with a dumb baler, with a baler, just flattened stick line tool at the bottom, just touch the fluid level. So they'll say, the fluid level is about 2,000 2,000 feet wire line measurement. Do you understand? But if you now add Xyme, before you even open the well to flow, you say let us run to tag the fluid level. You might see that fluid level has already come to maybe 200 feet. 200 feet wire line measurement, meaning that this thing has started pushing, that has pushed all that oil from the reservoir out into the well bore, and as such it's coming to surface. Yes, if you are using sucker rod, yes, you will now see that your pump rate is higher, but without even the sucker rod, if you are using, if you just have with the kind of reservoirs we have in Nigeria, the pressures increase immediately. So you see your pressure, by the time you open your well, you see your pressures increase immediately. Next slide, guys. Okay, so these are, we just also telling you what are your kind of problems. Do you have sand leaking problems? Apply your sand screen to take care of the sand, but at the same time, after that, apply Xyme. So in that same over sanded well, will now still produce oil for you. Fracturing jobs, you know, they say, okay, use, before you start applying frac chemicals, that's the chemical. If you are doing hydraulic fracturing, most time what we recommend is frac, then put Xyme. But if you are using frac chemicals, we say apply Xyme first before you do your frac chemicals. So the same, so if you are doing acidization, we'll say sometimes, oh, apply your acid before you now apply Xyme. Next slide, guys. Okay, this is me just playing up and down. Next slide, next slide. I don't know why I'm even taking this slide off. Next. Okay, so these are some SPE papers. We're rounding up. So you can verify, check all the results in various clients of where Xyme has been applied and the kind of results they have gotten. So you can check this, read those SPE papers and get further insight with regards to Xyme. Next slide, guys. Okay, so it's just the same, some paper. Next slide. So yeah, next slide. Yeah, so this is how you differentiate. Next slide, guys. Yeah, so this is how you differentiate between, and I mentioned this earlier, and I told you we are going to come back to it. How you differentiate between a questionable bioenzyme catalyst solution for your well versus the Xyme in itself. You know, so that's order, very critical. Is it fermentation or not? Fermenting smell that you have, so it's very critical. Beyond that, every other thing still applies that you can check, you know. Next slide, guys. Okay, so this is kind of a repetition. It has to still pass all these tests. Any one that says it's a good biological enzyme treatment should be able to pass all these tests. Next slide. Okay, thank you. So just to add, let me just now give you the example in Niger Delta. So in Niger Delta, we got a client came and told us, okay, you have been talking about this too much, Onyeka. How do we apply this? And I gave them the Xyme data sheet, and they filled up all the data and said, okay, if it works in the first well, we'll give you more wells, because I can't give you mine. They had 11 wells, so they gave us one. Said, let's apply this. So we checked it. That well was doing 185 barrels per day. That single well was doing 185 barrels. It had some kind of GOR, that's gas oil ratio. Then also, when we got to the field, by the time we got that data, we looked at it, we were able to prepare the equipment that we're going to use. So we now decided, for them, their tubings were clean. We now decided, okay, we're going to go with a pump. We went with slick line and a pump. You understand? So it had tanks, mixing tanks, all of that. So we got to the location. You understand? Your well is actually depleted. And when we did that check, we confirmed yes. Another thing that we saw was that the wells that they had there, they had a gas well. It's a isolated platform. They had a gas well on gas generator, on that location. They were using gas from 3 other wells to power that generator. You know, to power that generator that serves light to, they had accommodation, had everything, you know, fridge, everything, washing machine, everything connected on that platform. So they had gas from 3 wells connected to that generator, powering it up. So we kicked off. They now told us, look, this thing we don't want, if you know you're not going to get results, don't disturb us, because this gas coming out here is still important. And you told us this thing doesn't work for gas. You understand? You know, we don't promise that, but as I share, you get the story. So 185 barrels, producing some gas. We ran with stick line, checked that the well was free, ran in hole. Now came back to surface, mixed 5% of Xyme. After mixing 5% of Xyme, pumped it down the well. We were supposed to unlock it after the 3rd day, but they had some mechanical challenges on their platform, so they told us not to open the well. So it stayed 1 more day. For me, better. You understand? Because the more it will unlock more oil from the formation. So we stayed. On the 4th day, we opened it. What we initially noticed, we noticed an increase in the hissing sound. That's the gas. It became too loud. So what they did was, quickly disconnected and let's even first be dealing with the gas. So they took the gas and used that single well to be powering the generator. It was even too much. At the point, that's what they told us. That single well, so the gas had increased. Then when we started flowing, we flowed for like 3-4 days. We stabilized at 520 barrels from 185. We stabilized at 520 barrels a day for them in that particular one. What did they do? They gave us 2 more wells. So in that entire field, I think it was doing 600-ish or so. So the other wells were almost doing nothing, too much water there. By the time we were done with those 3 wells, we started doing 1,830 just with 3 wells. That's when we left, because we only planned, we had extra for 2 more wells. We didn't have much. They wanted to, come and do more, because now they had that kind of result. So that's the kind of result. That's not outside here. In here, we have NDAs signed, that we can't share who those clients are, but that's the kind of result we have obtained here. All right, thank you very much. If you have questions, arguments, draggings, let me know about it. Or no questions, I'm fine. But I'm on the side if you still want to discuss anything. I will hand you over to Eva. Is Eva around for the Xyme? Yes. Oh, okay. So who is doing the Xyme? You want to do the Xyme stuff? No, we are not doing that. Okay. So if you have any questions, I'm around, still here. All the other sales engineers are around. Thank you very much for coming. Thank you.